Good morning and welcome to Algebra 1 for Monday, May the 18th. Today we're going to do a little review of the things we've been doing to graph a quadratic equation from all three forms. The purpose for this is to get ready for a test. My plan is for us to have our test on Thursday of this week. It's going to be an easy test if you ask me. It's basically going to be one prompt for each of the three forms. You can use your notes, you can use my videos, you can use the explanations of the prompts I'm giving you. There's obviously no lack of things that you can do to prepare for this test. And again, of course, I'm giving it to you on Thursday. I'd like it before the end of Friday, so midnight Friday, plenty of time. So, brief review, guys. All right, we talked about graphing a quadratic equation. We explained a quadratic equation is one in which the highest power, we say, is squared. So y equals something x squared, plus or minus an x, plus or minus a constant. Those can be there, those might not be there. But there's got to be an x squared term, and that makes a parabola. It doesn't graph a line, it graphs a parabola, which looks like either a u or an upside down u. So the three forms we learned to graph a quadratic. The first was vertex form. In vertex form, it is y equals a times x minus h squared plus k. The form is basically just a template. What it tells you is that there can be a number, a, which creates either an upward-facing parabola if it's positive or a downward-facing parabola if it's negative. It could be very narrow if it's a large number. It could be very wide if it's a fraction. The h and the k is where the vertex is. So we said the vertex, capital V, is at the coordinate hk. It's supposed to say minus in there, so if it does say minus in the problem, the h value is actually a positive number. It's the opposite of what you see. The k value here just says plus k, so if k is a positive number, it's a positive number. If it says minus something, it's a negative number. Okay. From there, we make a t-table, which we've done a lot of, and then we graph it. Remember, your vertex goes in the middle of your t-table. So if the coordinate, and I'll just give you an example, let's just say y equals 2 parenthesis x plus 3 squared minus 1. As an example, where's the vertex? Well, it says x plus 3 in the parentheses, but it's supposed to say minus. So it's a negative number. So the vertex is negative 3, comma, and then what that says, negative 1. I found my vertex, so then I would make a t-table where you have your x and your y values, and you put the vertex right there in the middle of it, and then you move 2 values below it and 2 values above it. So what's more negative than negative 3? Well, that's negative 4 and negative 5. What's more positive than negative 3? That's negative 2 and negative 1. In order to solve the problem, we would just plug each value into the equation to see what the output's going to be. I'll show you an example. So y equals 2 parenthesis negative 5 plus 3 squared minus 1. Negative 5 plus 3 is negative 2 squared minus 1. Negative 2 squared is 4. 2 times 4 is 8. 8 minus 1 is 7. So that would be a 7. And so would the other symmetric value. So if 2 below was a 7, 2 above will be a 7 also. Then you plug in negative 4, you do the same thing. I'm going to just talk through this one because I ran out of room. Negative 4 plus 3 is negative 1. And negative 1 squared is 1. And 1 times 2 is 2. And 2 minus 1 is 1. And yes, you could just plug that in, or yes, you could use a calculator, but that should be the result you find. And then you graph it. This is all negative x and a lot of positive y. So x goes negative 1, negative 2, 3, 4, and 5, because that's as far as I have to go. And y goes up to 7, so that's as far as I go. I don't need to worry about any positive x. I do need to worry about one negative y because it went down to -1. And now you graph them, and it's just as easy as plotting points, which you have to be careful with. -5, 7. -5, 7's up here, so I'm actually in my notations. I'm just going to erase that for a minute. -5, 7's up here. -4, 1 is over here. -3, -1 is over there. -2, 1's over here. -1, 7's up there. And this would be my parabola. And we'd say that the vertex, which is on the bottom of this parabola, is a minimum. It opens up. We also knew that because the a value here was positive, +2. And we can see that it's decreasing to the vertex and increasing away from the vertex. All right, vertex form reviewed. What else did we have for our forms? Well, the next thing we talked about was intercept form, also called factored form, but I prefer intercept at this point in time because it tells you more for your purposes today than factored form does. Intercept form is y equals a parentheses x minus p parentheses x minus q. With intercept form, you were told what the x-intercepts are. They are the p and the q. So p and q are the x-intercepts. And again, at this point in the year, I shouldn't have to tell you what an x-intercept is, but it's the point on the x-axis where the parabola will cross through. It's supposed to say minus in those parentheses, so if it does say minus, the p and the q, they're actually positive numbers. If it were to say plus something, well, because it's supposed to say minus, that would make the p and the q negative numbers. And after you find the p and the q, to find the vertex, you want to start off by finding the x value. The x value is the p plus the q all divided by 2. So whatever the x-intercepts were, you add them together and you divide by 2 to find the average. And then you plug in to find the y value. And then you make a t-table as always. I'm sorry, we actually made an easier way. Forget the t-table for this one. This one actually is easier to graph. Don't worry about the t-table for intercept form. Just graph the vertex and p and q, because that's going to actually give you the curve. You don't have to worry about the t-table in the intercept form. It actually is kind of easier. Here's your example. Y equals, I'll keep it nice and easy, x plus 2 parentheses x minus 6. Okay, can you tell me what the values will be? Well, p and q are the first things to identify. P is -2 and q is +6. It's the opposite of the signs you see inside the parentheses. The x value of the vertex will be -2 plus 6 divided by 2. -2 plus 6 is 4, and 4 divided by 2 is 2. So I found the x value of the vertex. Now I have to plug it in to find out what the y value is. So when x is 2, 2 plus 2 is 4, and 2 minus 6 is -4. It's -16. So the vertex for this parabola is 2, -16. Okay, well, I'm just going to graph that for you so we have some conclusion here. Clearly, I'm going to have to go pretty far negative on the y-axis here. I have p and q of -2 and +6, so I have to go to -2 and +6 at least. -2 is 1, +6 is the other. I graphed my x-intercepts, p and q. And now the vertex, 2, -16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So way down there. 2 -16s over here. And now I have my curve. So I'm going to just make a curve out of it. Don't make it a V. Make it a U. Make it a curve. Good to go. Okay, that's intercept form. Again, the vertex for this example was a minimum because it opened up. It decreases down to the vertex, increases away from it. We talk about it left to right. And the last form you had to worry about was standard form, the most current one. Standard form, y equals a x squared plus b x plus c. A, b, c are numbers. If the term isn't there, the number is 0. The x squared term will always have to be there, so a is a number you have to identify. If the x term, the middle term, isn't present, b is 0. If it is present, it's whatever the coefficient is. The c term, the last one, is the constant, and if it's there, it's whatever the number says. If it's missing, it's a 0. To find the vertex, what did we do? Well, we used a very little equation, x equals negative b over 2a. That found the x value of the vertex. And then we plug it in to find y. Then we make a t-table. Okay. And graph it. You've had a lot of examples of this very recently. If you want another one, I'll give you one now. So, let's say that we have an equation. I'll keep it again kind of simple. Y equals x squared minus 3x minus 4. Okay? X squared minus 3x minus 4. Identify the ABC. A is the coefficient of x squared. There's no visible number there, so it's the number 1. B is the coefficient of the x term. It's negative 3. And C is the constant, negative 4. So far, so good. Now we identify the x value of the vertex. So x equals negative b. Now that's negative 3 over 2a, 2 times 1. Negative 3 is 3. 2 over 1 is 2. So 3/2 is the x value of the vertex. It is what it is. So 3/2 or 1 1/2. It's fine. Okay? Now, yes, you can plug in 1 1/2 into the equation. It's not that hard. It's a little harder than I've been doing because I'm going to leave it as a fraction. I just made this one up, so it worked out to be a fraction. Oops, oh well. 3/2 squared minus 3 times 3/2 minus 4. It is what it is. 3/2 squared, so 3/2 times 3/2 is 9/4. 3 times 3 over 2 is 9/2 minus 4. Well, I got fractions. I'm going to make just common denominators just to get it out of the way. So we got 9/4 minus, well, 9/2 is actually 18/4, and 4 is 16/4. Again, all we're doing is getting common denominators so that we can add and subtract appropriately. 9/4, 4 was the best common denominator. So what's 9/4 minus 18/4? What's negative 9/4? Minus 16/4. Negative 9 minus 16 more is negative 25/4. Okay, what is that? That's going to be negative 6 1/4. All right, so fine, it's a fraction. So negative 6 1/4, not the best thing that I've ever seen in my life, but it is what it is. Obviously, your example on the test will be far easier and thought out ahead of time, unlike this example. And then you make a t-table and graph it. I'm not going to bother to do that with this example. It's got fractions. It's messier than I want it to be. Put it to rest, but you can always watch any of the previous 3 days videos if you want standard form examples, better than the one I'm giving you right now. All right. So here's all I need you to do, okay? Today's Monday. There's plenty of time. I'd like you to make yourself just a quick sheet of notes. Could be what I just went over with a better example for the standard form. It could be from your previous notes. It could be the quiz you took on the first two forms, plus your notes for standard. Whatever it is, I'd like you to just get something together so that when your test comes on Thursday, and tests are obviously worth a lot, you nail it, you get it done, you don't delay it, you don't wait over the weekend, you get it done on time and right, and you have an excellent grade. Right? Most of you have great grades right now, and that's fantastic. I'm actually very proud of the vast majority of you that are doing the work, that are putting in the effort, that are emailing me when you have questions. You're doing great, all right? If you have any questions, please let me know. Otherwise, there's no homework but to try to prepare your, we'll call it a cheat sheet for your test. Have a great day.